Okay. Thank you, Hatano Sensei. Hello, everyone. Thank you very much for coming. I'm happy to be here today. I start to talk about Kaken's technical approach for fusion realization. My name is Ikemoto, joined to Kaken in 2017. Firstly, I start with introduction on our company. Let's move on to our fusion R&D activity, lithium, and beryllium. If you have any questions, I'm very happy. I start with Kaken's introduction. Kaken have established in 1978. This year is 44th year. There are two offices. One head office is in Mito, Ibaraki Prefecture. The other office is in Hokuto City, south of Mito City. Our fusion R&D activities are in Hokuto office. Our business is introduced. Head office Mito Institute has radiation control area and nuclear fusion handling area. Using these areas, nuclear analysis and various experiments are interested. Others, chemical analysis, such as aspect analysis, are provided. In fusion technology Hokuto office, something beryllium production and treating sampling or removing equipment are producing. Next is our fusion R&D history. We have been developing since 1990s, just when speaker was born. In 1990s, we developed oxygen ion conductor electrolysis system. Around 2000, we developed lithium isotope separation and hydrogen isotope separation. In 2010, we constructed a detonation system for glow box and rotated electrode process for beryllium. Recently, we are working on lithium and beryllium production system and new detonation system. On today's presentation, I will explain red squares. These outcomes are including collaborative research. From now, I will explain individual elements. Start with hydrogen isotope separation. Cryogenic distillation is widely used in fusion reactor. However, this process is low energy efficiency because hydrogen gas is liquefied by cooling. Small scale is not better. So, other system able to separate isotopes having high energy efficiency is required. We have developed paradigm platinum alloy or paradigm platinum catalyst for packing DC current with University of Toyama. Experiment result is this figure. Like this figure, hydrogen isotope H, D, and T are separable in room temperature. This method is used in isotope effect to generate palladium or platinum hydride. This method is compact, high efficiency, and separable on room temperature. Handling tritium concentration range on fusion reactor is varied. The higher is in fuel, the lower is the environment. About environmental tritium, collecting background data is essential before operating fusion reactor because fusion reactor is tritium steadily. Then we constructed environmental tritium laboratory. Equipment electrolytic enrichment, freezing dry, combustion, and reflux, and low background ligid scintillation counting. Therefore, we can measure tritium concentration of various type samples in our laboratory. We are producing tritium products. For example, movable type tritium sampler, water freezing type, and something deterioration system, for example, glow box or laboratory. We flexibly customize our device to meet your required specimen. If you wish any tritium devices, please contact us. Next, move on to lithium. Lithium isotope separation, as mentioned in addition, trying production method for tritium bridging material pebble, lithium titanate, lithium silicate, and lithium oxide. Present emergent method is used, trying extrusion method and cohesion method. Other method not introduced is also trying. Finally, I talk about beryllium. Kaken has beryllium laboratory in Japan. Institute or company having beryllium handling area is very few. It is known if we inhale beryllium powder, it causes lung cancer. So we have to wear protection clothes and dust masks. In our beryllium room, we use beryllium, not only powder, also liquid or gases. In our beryllium room, we have these devices. Therefore, we can do various type experiment using beryllium. Beryllium on fusion is used as neutron multiplier. In Japan, neutron multiplier is produced by rotated electrode process, lead. To produce lead, beryllium or beryllium alloy, lot of alloy is consequence. Kaken has SPS, back sintering device, and lead to produce pebble. This is all my presentation. Thank you for attention and listening.